Hello everyone, my name is Igor Novikov, I'm from GeoSplit, and today I would like to share with you an innovative technology which is called dynamic monitoring of inflow in horizontal wells with a high multistage hydraulic fracturing under reservoir condition of Bazhenov formation. So let's get started. The marker-based technology has the 5 main steps. The first step is the synthesis of the quantum markers. So we produce them in our manufacturing, and they are different. So they can be contacted to water, to oil, and to gas. So second step is the placement of the marked propant in the formation. For each stage we use different codes to identify the inflow differences. And this marked propant needs to be pumped as a regular propant as the last propant pack for each stage. And the third step, we collect the samples at the surface once the well is opened and the fluid is coming to the surface. So we take these samples and send them to the laboratory. They analyze it and give us a result. So result says how much influence from each port and what kind of fluid from each port comes. And this data presented in percentage. So this is quantitative data. And the last step, this information might be used to make a decision of how develop the oil field. At this slide, you can see how the polymer matrix works. At the picture, you can see the polymer net, and this polymer net is very stable, and it can't be destroyed by any acid, or H2S, or CO2, or any other aggressive fluids. So this net gives even more strength to the propant. So inside this polymer net, you can see the powder. This is the filler, and this filler is designed to be reacted either with water, with gas, or with oil. And the spherical particles inside this filler is the markers. So it means that if this filler designed to be reacted with the water, once the water going to this surface, the filler is swallowed and push the markers from inside of the polymer matrix to the surface, and then water can grab these markers and bring them to the surface. The same procedure is for the oil filler and for the gas. And important thing that if there is no any flow, the markers are not released. So they stay at the surface of the polymer matrix and don't go anywhere. That is the main thing which gives us an information if there is any flow from any part or not. And on the pictures below, you can see the 3 steps how they can be released. So that's, as I said, if there is a flow, the markers are going to the surface of the matrix and going to the surface. If not, so they stay in the matrix and not go anywhere. At the right 2 pictures, you can see the oil field maps, and on the left bottom there is a well profile. As you can see, here is the 15 stage hydraulic fracturing stage per each well, and there are 4 wells. Each horizontal section is around 1,500 meters. Temperature is 117 degrees C of the formation, and the reservoir pressure is around 331 atmosphere. This is the initial pressure. And each port contained 90 tons of propant, and 15 of them were marked. Reservoir has hard to recover deposits, which means that the half length of each hydraulic fracturing length is longer than if it were sedimentary formation. This project has some objectives and stages, and the research problem statement is the main idea of getting more information based on the monitoring of horizontal wells, and this information might be used to create some tools to optimize development process for multistage fracturing and drilling and other processes. And what it gives us? It gives the unique geological and geophysical characteristics of the reservoir. In case if there is a poor geological knowledge of the development object, And sometimes even there is an absence of reservoir pressure maintenance system and sharp drop in the energy state of the formation. So in this case, of course, we need to drill more injected wells and run them across the production well. At some stage of the project, there are laboratory testing of market diagnostics. Prior, we run this or use this technology in the real wells. Then field test in comparison with PLT, which is quite good because we can compare and see if there are any difference or not. And third is a comprehensive analysis of information obtained during market monitoring. So it also gives us some more data to analyze. And the last one is development of a strategy for future integration of the applied approach. So for this well, the field test was done. As you can see, it was done with spectral noise logging together. So we install markers in the well and get the information from the laboratory and then compare this result with the spectral noise logging. So as you can see, the difference between taking the samples and running PLT is around 1 or 2 weeks. And in general, the correlation is quite good. So you see on the red squares, the areas where it's a very good match. So it means that the difference is not really big. So it means that we can trust this information and we can use it for the future decision making. And during this time, the water cut was around 9%. When we look on the flow profile in dynamics, we see the very interesting picture. And there are three graphs here, and the top left graph shows us the fluid rate in percentage, the top right in the units, which is cubic meters per day, and the bottom one is the daily cumulative production. We can analyze the green curves here, and by looking on them, we can say that only 30% of the 15 ports give us any inflow. So there are 6 actually ports which are driven this well and give some fluid from the formation, and other 9 ports mostly not working or give us very little volume of the fluid. And it were 12 samples taken during the year, so approximately every month. And by cumulative production, we can say that port number 4, number 12, and number 1 give us the most inflow, and some ports gives us around 0. So analyzing this information, we can see how the formation works and particular well works. And also we can predict any future processes. Here's an example of identification of fracture propagation in the tight rocks. If you look on the port number 2 and 3, you can see there is almost no any inflow from the ports, and by taking into account the geology of this depth, we can see that it's a tight rock, and it means that it's very difficult to get any inflow from this rock. Even if you do the fracturing, the length of the fracture might be not that long, or it might be somewhere in different directions. So in this case, the inflow is still around 0, not like the other parts which are in the good formation conditions. By using marker-based technology, you can even identify the conductivity relation between wells, between production and injection wells. Like in this case, you can see the red arrows show how the well responds from the production well to the injection well. When the injection well was turned on, you can see this response is just different, has a difference to compare with the previous samples. So it's just changed the picture of the inflow profile, and this response was identified, as you can see. And if there is a filtration connection between the wells, so for sure this will be identified when you pump some water or
any other liquid to the injection well. And also this connection might use to identify or to see the picture how your reservoir works and what's the connection in your reservoir. And it helps you to also make some future predictions. There are some integration strategy approaches, and we separate them by segments. Then this implementation of the digital tool for predictive analytics contains the adaptation of available geological and hydrodynamic models, which are already exist, and the tracking down the implicit correlation dependencies, which are not obvious, but sometimes they give you the clue or the identification of any processes which are very hard to identify without additional data, and also creating non-geological models through the identification of functional relationship between wells using the machine learning algorithm, which is very interesting because by humans it's might not be done because it takes a lot of time, and this algorithm can save us much time and gives us more accurate data. Here are some main conclusions. In the first one is in oil and gas development companies, it's very important to get the proof data, and the tracer or market-based technology gives you this information, and based on it you can predict your future process. Second, that in this oil field, which is called Srednyenazemskaya oil field, the well flow profile in horizontal well changes dynamically. Some additional data was obtained in this productive formation. Dynamics of flow profile transition was identified between injection and production wells. Predominant performance of a dome reservoir area. Identification of fracture propagation in the tight rocks. Interference of ringing wells and estimated identification of the reservoir area with a highly hydraulic permeability. And on top of this, there is a strategy was discovered of the new approach, integration development with implementation of digital tools for predictive analysis, which gives you additional value and additional information which you might not be found by any other technique. Thank you for your attention, and now I'm ready for Q&A session.